Hi, welcome to the second part of solving systems using the elimination method. So we're on the second page of the notes, and I just wanted to revisit the steps on how to solve a system using elimination. This time, though, paying specific attention to step number 2. So steps are the same. Each equation must be in standard form, but multiply one or both of the equations so that one variable can be eliminated. Okay, so make them opposites. So I want you to write exact opposite terms again. Exact opposite terms. So when you add them, they equal 0. So 2x and negative 2x are exact opposite terms. Negative y and y are exact opposite terms. And 3x and negative 3x, again, exact opposite terms. Not just opposite signs, but exact opposite terms. When you add 3x and negative 3x, you get 0, right? They eliminate. All right, so that's the step that we're going to focus on today. Everything else is the same. So let's start off by looking at number 5. So if I look at my equations, the first one's in standard form, the second one's in standard form. All right, so let's take a look to pencil mark trick. That negative 5y. Do I have exact opposite terms? Well, I have 2x plus 2x, that will give me 4x, and I have y plus negative 5y, which would get me negative 4y, so nothing eliminates. This is where I have to go to a step number 2, which is multiply one or both of the equations so that you can get the exact opposite terms. If you look here, this is 2x and this is 2x. So 2x and 2x, well, if only one of them was negative 2x, I'd be able to eliminate them. So I'm going to multiply the top equation by a number that would result in negative 2x. So think about what number it is, and it is negative 1. So negative 2x, I essentially am using the distributive property. Negative 2x. So negative 1 times y is negative 1y. Negative 1 times negative 5 is positive 5. Make sure when you multiply an equation, you multiply every term by that number. I don't have to touch a second equation at all, so I'm just going to copy it over. 2x plus negative 5y equals 13. Now I have terms that will eliminate if I add them. So let's eliminate the x's. And let's add. I have negative 1y plus negative 5y. Gets me negative 6y equals 18. And I want to divide by negative 6. And I get y is equal to negative 3. Now I'm going to go back and substitute my negative 3 into one of my typed equations, okay? When we go substitute the first term to find the second one, always use the typed equation. Or when you check your answer on Desmos, always type in the typed equations. Because what if we made a mistake when we multiplied by negative 1? So I'm going to use the first one. So 2x plus y equals negative 5. And I'm going to substitute negative 3 in for y. And then I'm just solving a two-step equation. Plus 3. 2x equals negative 2. Divide by 2. X equals negative 1. So my solution is negative 1, negative 3. In step number 8, check on Desmos. Remember, you do that. All right, let's check it. Typed in right there, negative 1, negative 3. So that's the point at which those. All right, so let's take a look at number 6. Looking at them, they're both in standard form. Do I have exact opposite terms? I don't, even though that this is 3x and this is negative 2x. They're opposites. But when I add them, I'm still left with 1x. So I need those exact opposite terms. I want you to look, when you have the same coefficient, 3 and 3, I can just make one of them negative. So let's multiply. Let's do the bottom one by negative 1. Again, you could do the top one by negative 1, and you should still get the same answer. Negative 1 times negative 2x is positive 2x. don't lose the signs. Negative 1 times 3y is negative 3y. And negative 1 times negative 5 is 5. Now I don't have to touch the top equation at all, so I'm just going to copy it over. 3x plus 3y equals 15. Now I have exact opposite terms. My 3y and my negative 3y, they add and eliminate. All right, 3x plus 2x is 5x. 5 plus 15 is 20. And now let's solve for x. Divide by 5, and x equals 4. Now I'm going to go back and type it in, or substitute into one of my original equations. I'm going to choose the top one just because there's no negatives. So I'll choose 3x plus 3y equals 15. And remember, x is equal to 4, so I'm going to substitute 4 in for x. All right, so let's solve. First multiply, I got 12 plus 3y equals 15. Minus 12 minus 12. 3y equals 3. And we'll divide both sides by 3. And y equals 1. So my ordered pair is 4, 1. Be careful, make sure that you write the values in the correct spot. Let's check it on Desmos. 4, 1.
May I have your attention, please?
All right,
This
so
is
let's
Matt
take a
Wood.
look.
Please call extension
4,
2233
1.
for Melissa Tungate. Thank
Okay,
you.
is my solution. Now 7, we're going to skip number 7 because it's the same thing, right? I would look at my terms and I would make one of these negative. So let's look at number 8. Number 8's a little different. Okay, so they're both in standard form, but if I were to add them, nothing would eliminate. And I don't have those same coefficients, but I do have positive 2x and negative x. So I already have one that's positive and one that's negative. So I can multiply the bottom equation this time by what number to get to eliminate with 2x? Well, think it would have to be, the end result would have to be negative 2x. And so I know if I multiply the bottom by 2, I should get 2 times negative x is negative 2x. 2 times 3y is 6y. And 2 times negative 12 is negative 24. I don't have to touch the top one. I'm just going to carry it over. And now I'm set up where I can eliminate. So I'll make my big addition problem, eliminate my x terms, and I now have 7y is equal to negative 21. I'll divide both sides by 7 and get y is equal to negative 3. Now I want to find my x term. I'm going to use my first equation because y is all by itself. So I have 2x plus y is equal to 3. 2x plus negative 3 is equal to 3. So I just substituted that. I'll add 3. 2x equals 6. And x equals 3. So my solution is 3, negative 3. Again, that's the point in which these two would intersect. Let's check it out. 3, negative 3, yes. And please note that when you type it into Desmos, typing the original typed equation, so these over here. All right, so we still only had to change one equation. Let's take a look at this one. So again, in standard form, but nothing will eliminate, although I have 1x and negative 3x. So if I can get this x term to have a 3 in front as a coefficient, it will eliminate. So let's multiply by 3, the whole equation. 3 times x is 3x. 3 times 2y is 6y. And 3 times 11 is 33. I don't have to change the bottom one, so I'm going to carry it over. And there we go. So we have them eliminated. I have 6y plus y is 7y. And then I have 33 minus 5 is 28. Divide both sides by 7. Y is equal to 4. Now it's up to you which equation you want to plug it back into. Either will work. The top one doesn't have any negatives. The bottom one has y by itself. So I'm going to actually do the top one. So I have x plus 2y equals 11. So x plus 2, instead of y, I'm going to substitute my 4, equals 11. X plus 8 equals 11. Minus 8 minus 8. X equals 3. My order pair is 3, 4. Let's check it out on. There we go, 3, 4. Now, if you were to get the 4 correct, or in this case, first term, but made a mistake here getting this term, then you could go back through this part of the problem and see if we made a mistake with a sign, or maybe we added instead of multiply. If you do get the 4 incorrect, go back through this part of the problem, but then you will have to redo to find your second coordinate. All right, we're going to skip number 10. So we have multiplied one of the equations, so the variable can be eliminated. The next two problems, we're going to have to multiply both equations. So this will I'm trying to think. This will make us go back into our memories about least common multiples, LCMs. So if I looked at how they're written here, I have negative 5x and 2x, 2y and 3y. Well, nothing's going to eliminate, even if I just multiply one of them. So I'm going to look at the terms, again, one being negative, one being positive. Let's think about least common multiple between 5 and 2. All right, so 5 and 2. So think 5, 10, 15, 20, 2, 4, 6, 8, 10, 12. Wait, I think I said 10. So I want one of the terms to be negative 10x and one to be 10x. Since this one has a negative sign, I'm going to multiply by 2, because 2 times negative 5 gets me negative 10x. And 2 times 2y gets me 4y. And 2 times 32 gets me 64. Now I need this term to become a 10x. We already have the negative 10x. So I'm just going to multiply this entire equation by 5. 5 times 2x is 10x. 5 times 3y is 15y. And 5 times 10 is 50. All right, so let's make a big addition problem. And let's go ahead and start the process. Those two terms eliminate. 4y plus 15y is 19y. 64 plus 50, by all means, please use your calculators, okay, is 114. Well, let's hope 114 divides evenly by 19. Okay, when I divide that, I get 6. So y equals 6. I'm going to go back into my typed equations, and I'm going to choose to substitute the 6 into this one, just because there are no negatives. So I have 2x plus 3y equals 10. I'll substitute the 3 times 6 equals 10. And then 2x plus 18 equals 10. Two-step equation. Let's subtract 18 from both sides. 2x equals negative 8. Don't lose the negative. Divide by 2. X equals negative 4. Ooh, that was a lot of work. So my solution is negative 4, 6. All right, so with all that work, let's go definitely check. Negative 4, 6. Let's hope. There it is. Again, where my two lines intersect. Oh, again, we're going to use the idea of least common multiples. All right. So we have 2x and negative 3x, and then 5y and negative 4y. Let's actually eliminate the y terms. You could eliminate the x terms. But let's eliminate the y terms. So think, what's the least common multiple of 5 and 4? Like 5, 10, 15, 20, 25, 4, 8, 12, 16, 20. Oh, I think I said 20 2 times. Okay, since we already have one being negative and one being positive, let's just multiply the top by 4 to get 20y. So 4 times 2x is 8x. 4 times 5y is 20y. And then 4 times 26 is 104. Again, use your calculators. You're going to get big numbers, bigger numbers that you probably can't do in your head, and that's totally fine. All right, I got to multiply the bottom by 5. 5 times negative 3x is negative 15x. 5 times negative 4y is negative 20y. And 5 times negative 5 times negative 25 should be negative 125. All right, now I'm ready to complete the process. So eliminate the 20y, negative 20y. I got 8 minus 15x, or 8 plus negative 15x. I got negative 7y. I have 104 minus 125. I get negative 21. Divide both sides by negative 7. Y equals 3. Again, back up into one of my typed equations. I'm going to choose my first one. No negatives. So 2x plus 5 instead of y. I'll substitute 3 equals 26. 2x plus 15 equals 26 minus 15. 2x equals what, 11? And so then x equals, if I divide by 2, I'm going to get a decimal, 5.5. Let's see if that's right. 5.5, comma 3. Wait a second, I have 3 comma 4? Let's see, what to have? 3 comma 4. 3 comma 4. 2x plus 5y, negative 3x. Negative, ooh, no, 2x plus 5 times, I didn't get the y. What's my y? 4. Let's see, 104, negative 21, 2x plus 5y equals 26, negative 3x plus negative 4y equals negative 25. Negative 3x plus negative 4y equals negative 25. 2x plus 5y equals 26. 3. What is going on? Oh, I see what I did. Look here. I was adding the x's and instead I put y. So back up here. All right. So this is negative 7. X equals negative 21. Divide by negative 7 and x equals 3. Okay, so right then and there, I could use Desmos, and I found my own mistake. Okay. So now, I had to change my first coordinate, so I got to go back and change my second. All right, so now I'm going to plug 3 in for x. Okay? Instead of y. So now I got 6 plus 5y equals 26. Minus 6. 5y equals 20. All right, these numbers are looking better. Divide by 5y equals 4. So I have 3 comma 4. And I'm pretty sure that's what was 3 comma 4. So thanks for watching. This is where we are looking at step number 2, where we have to multiply one or both equations. Okay, so step number 2 is super important here. We'll look at word problems next video. All right, thanks for watching.